I am now officially one step closer to possibly obliterating my minivan's transmission. That's right, I've made progress on the transmission controller. Hey, I'm Tom. Remember this silly thing? Yeah, it's getting even better. This video is sort of a part 2 for this silly project for the Odyssey, so if you haven't seen the first video, go ahead and check that out up there. As a recap, in the last video, I basically explained my research and started building the transmission controller, and then I had to stop because I needed some extra resources. Fast forward about a week, and the parts I needed arrived. These parts included breadboards, perf boards, and some micro switches that I can use for the shifter. The most important thing I needed were the breadboards. The small ones I already had on hand, just weren't large enough to neatly arrange everything I needed. Having these larger breadboards finally allowed me to add the 12-volt control circuitry to this whole project. Now real quick, let's talk about how that 12-volt control circuit works. In short, what it does is it basically acts as like a light switch that the Arduino can control. If you're already a little familiar about electronics, it's sort of like a relay, but without any moving parts and really kind of dependent on voltages. Essentially, whenever the Arduino outputs 5 volts, this transistor allows some current to flow, which causes a voltage drop across this resistor. This makes the MOSFET controlling the 12-volt supply allow current flow, since the pin that controls it now has a voltage much lower than its input pin due to the voltage drop caused by current flowing through the resistor right here. If that's confusing to you, all you need to know, putting 5 volts here makes 12-volt output turn on. In order to test this circuit, I grabbed a 12-volt power supply I had laying around and searched for a good test load. Eventually I settled for this spare fan I have for a server, and it's actually a great load for several reasons. First of all, it runs on 12 volts, so I know I won't kill it. Second, based on the specifications of this fan, it uses a little more power than one of the solenoids would. So if the circuit can handle this, it should handle one of the solenoids no problem at all. And lastly, it has this really nice little connector on the bottom, and that makes it a lot easier for me to put jumper wires into and connect to the circuit for testing. Power brick and test load in hand, I cautiously hooked them up to the circuit, and this is right about where I'd expect something to fail catastrophically. Amazingly, nothing blew up. The fan roared to life as expected. Oh. Yeah, it works! And it even turned off when it should as I scrolled through the gears. With that sorted out, I had to repeat this 6 more times, so I'd have it for each solenoid. Honestly, I was really expecting something to blow up. I've done a lot of really simple circuit work before, but I've never pieced together something of my own design that has a transistor in it and not have anything blow up. So you've got no idea how accomplished I feel for actually doing this without anything exploding, breaking, anything like that. As you can see, this is why I needed the larger breadboards. The individual circuit per channel isn't that large, but when you have 7 of them in total, it can get pretty large pretty quickly. With breadboard bench testing completed, I went ahead and made a list of all the wires on the engine and transmission harness that I would need for this project. This way I would know the minimum number of pins I would need on a connector to put on this controller. In order to make installation much easier, I spent hours trying to find the same manufacturer and series connector that Honda originally used. And this would allow me to simply transfer pins over to the new connectors instead of having to snip the existing pin and put a new one on an already short harness. Part of my goal here is to prevent this from being a destructive part to install. If for some reason you need or want to go back to the factory ECU and restore automatic functionality, you should be able to do that in under an afternoon. Plus, you won't need to find a new harness or anything because you've cut up your old one. All you'll need to do is move all the pins back to their original locations on the factory connectors. Of course, I wasn't able to find an identical connector to the one Honda used. However, I did know what series they wound up using, so that let me pick from a wide array of options as to which connector I could use. I ran into issues with limited or no stock on many offerings. However, I was able to settle on this one connector. The part I wound up going with is a 28-pin header connector, which is actually split into 2 parts. There's a 12 and a 16-pin connector that connects to it. I then made a graphic to show where each pin would go on that connector. And this will help me when it finally comes time to put all this on a perf board and eventually PCB. The larger 16-pin connector will be used for anything connected to the engine and transmission harness, whereas the 12-pin connector will be exclusively used for user-added wiring. This would include things such as your shift lever, gear indicator, all that kind of stuff. Keeping these as 2 separate harnesses should actually really help streamline installation. That way you can actually construct your entire user-added harness without having to work inside of the vehicle. Plus, you can't mix the 2 connectors up, which would cause some serious damage if you did. So that's nice. The new ECU just arrived. Make sure you're subscribed because I'm going to be installing and testing it in next week's video, and you're not going to want to miss that. Maybe I'll launch a rod or something on the first start. Who knows what fun things might happen. Anyways, it's time to start putting the controller on a perf board and designing a little enclosure for it so everything is nice and safe inside the car. Until next week, let me know what you think down in the comments and stay classy.